the objectives of today's session is to explain the data mart and type of data mart and how these data warehouses or data marts are built, and to explain what exactly is dimensions and facts, what is the concept, and how they are used in data warehousing, build a data warehouse, learn the importance of these data dimensions and facts in data warehouse, distinguish between different types of dimensions. What are the different types of dimensions we have in the data warehousing concepts, explain the different types of facts we have, and understand hierarchy and the data warehouse architecture, hierarchical data and the data warehouse architecture, definition of a data mart. And so data warehouse is basically consolidated data from different various source systems. So it's a enterprise view or enterprise data view. So it's a collection of data from the enterprise, different departments of an enterprise. But a data mart is a very specific smaller version of a data warehouse where we will have data from a specific department. So to explain this, let me take an example. Let's say we have an enterprise which has say a manufacturing enterprise which has different departments. One department is their HR department, another department is their finance department, another one is their supply chain department. So all these are separate functions which operate separately, and they rarely interact with each other for their day-to-day operations. So for performing the day-to-day operations, they might not need to access data from the adjoining system. But a person who is sitting on top of all these three systems might need to access all the data to have a summarized view of all the data. That is data warehouse, which we already discussed. But these individual departments could have their own data needs, which is very specific to their own departments. Like a supply chain could have a transaction, OLTP transaction system to manage their supply chain data, the physical supply chain, which will be feeded into their transaction system, using which they will manage their supply intake, inventory, all the inventory management and everything. So that particular supply chain system will have their own subject own data warehouse, small data mart, which will have their which will fulfill their specific data needs for that particular department, the supply chain department. So that is called a data mart, which will have data from only that department, and it will deal with only that single subject. It won't have relation with the overall view of this enterprise. So these subject-oriented, subject-specific data warehouse are called data marts. And since the data mart is small and it looks onto a single orientation of data or a single department or single type of data, the building of that data mart would be easier than building a data warehouse, which has to have a whole enterprise view and has to suffice the data requirements or the analysis requirements for the whole enterprise. So building a data mart is obviously easier than building a whole data warehouse. So that's the difference between having a data warehouse and data mart. So if you see in this slide, you can see that there are data marts 1 to 9 inside a data warehouse. So what does that mean? So a data mart is a single subject specific data warehouses, and combining all these data warehouses, we will small data marts, we form a complete data warehouse. All these approaches of how to form a data marts from data warehouse and how to design data marts, we will discuss further in this class. So with this we move on to our next slide, and so I actually covered this slide is about the differences between the data warehouse and data marts. I think some of this which I already covered in my explanation, but let's go through this. Let's go through them one by one. So a data warehouse is an enterprise-wide data, and a data mart is a department-wide data. So which we just talked about. Multiple subject. A data warehouse is a multiple subject. It has multiple data from multiple subject areas, and data mart have data from single subject areas. And a data warehouse is from multiple data sources and limited data sources. Actually, this particular difference it can depend, like so this particular difference is like it is saying that you can have multiple data sources for data warehouse, but you can also have multiple data sources for data marts, but they will have a specific area from where they pick the data. So even if they have multiple data sources, they will have from specific data area. So both of them can have multiple data sources, but it will just be, the difference will only be the type of data which is being collected in a data warehouse and a data mart. Obviously a data warehouse, since it has all the data from all the departments, it will be huge, and maintenance cost will be huge because you will have to purchase huge servers to store the database and have all the systems in place to keep the data warehouse updated and everything. And on the other hand, the data mart is very specific. And so the data mart is very specific, so it will have a shorter, it will occupy smaller space, and it will be very subject specific, so you will not need so much, and it will so it will take shorter time to implement, because obviously it's a subject oriented data warehouse, so you won't need to analyze different aspects of the enterprise to form a data mart. You just have to focus on your business requirement and form a data mart within a shorter period of time. So that's what it means by when you say longer time to implement and shorter time to implement. So those are basic differences between the data warehouse and data mart. Now let's see what are the different types of data marts. So a data mart can be basically of 3 different types, as you see in the screen. Dependent data mart, independent data mart, and hybrid data mart. Theoretically, what is a dependent data mart? You can see by the name itself. A dependent data mart is a data mart which is dependent on something else. What is it dependent on? It's dependent on a data warehouse. So a dependent data mart is a data mart which is loaded from a data warehouse. So you first form a data warehouse, then you form a data mart. So basically you are supplying data to your data mart from a data warehouse. So it's the data mart is called a dependent data mart because it's dependent on the data warehouse to be updated before a data mart adjoining to it can be updated. So that's a dependent data mart. So why would somebody actually have a dependent data mart? So dependent data mart is something which you will have so that you don't have to access the whole data warehouse to fetch certain reports, and you want quick turnaround time from your source queries. If you fire the same source queries on this huge data warehouse, maybe you don't get the performance you need for your reporting. So you will form a data mart to get those. This is just one of the business scenarios. There could be multiple business scenarios. Maybe because of security reasons, the enterprise doesn't want to share the data between data from the data warehouse to a particular department. So they just want to give a particular section of the data. So for data security purpose, they will share a data mart, which is updated from the enterprise data warehouse. So those are the few reasons why you would actually have a data mart. There could be multiple business scenarios like this which would need somebody to have a data mart, in a dependent data mart. And and the next type of a data mart is independent data mart. So what is an independent data mart? Independent data mart is a data mart which it just depends on the OLTP source which is available to so the data is directly loaded from the transaction system into the data mart based on the requirement of the reports. So that is basically a independent data mart. So in this case, the data mart does not depend on a data warehouse to be updated before it is updated. And these data marts are basically used for small organizations and for very specific requirement for that organization, which can be easily developed. So if you see the dependent data mart, right, so in this case the implementation time is double. Like you have to first create a data warehouse and then you have to supply the data warehouse data to a data mart. So it's double work. So an independent data mart is a quick solution for quick requirements for these small organizations. So these organizations will plug their OLTP systems to the data marts and then create ad hoc reports or whatever reports they want in these data marts directly rather than going through a data warehouse. So that is called an independent data mart. And hybrid data mart is a mix of both independent and dependent. So to explain this, I will give you an example. Like in one of my projects, the scenario was that there was a customer relationship management system, and in that system we had surveys from different customers and consumers. These surveys are collected from online survey logs and then posted in the OLTP system. And from the OLTP system, the data was read into a OLAP system where the reporting was done on this, and the reporting was done on this OLAP system for customer quality, customer service quality management. But the problem was that they had another way of collecting the survey informations. Like they were collecting the survey information from the customer when they visit their kiosks, and they will ask them to fill up forms which are hard copy forms, written forms, and they will ask them to fill it up manually, and then they will collect those sheets, and the kiosk manager will enter these records and rate the data in an Excel sheet. So they will just collect the data in the form of Excel sheets. So there were multiple kiosks in different locations. So they will collect multiple Excel sheets. So there was a requirement where you had to get the data from the OLTP system and the Excel sheets and the data warehouse. Most of the business scenarios will be hybrid. There is nothing clear cut in the real world, so there will always be complexity. So in this scenario, we had to get the file data, and combine the reports from the file and combine the reports from the data warehouse and form a consolidated report. So this is a kind of data mart where you access the data from the data warehouse, which is from the OLTP system, and to the OLAP, and then we do the report, and there is a data warehouse on top of that. That data warehouse data is collected, and then also the data from these files which are manually filled by the consumers, and then there is a consolidated report generated in the data mart. So this type of data mart is called a hybrid data mart. So as we discussed just now about the data warehouse and data mart and everything, so now we will see how these data warehouses or data marts are built from the requirement of a client. So when we go to a client, he doesn't tell you to build a data warehouse for us, right? He will have a business requirement. He will say that, okay, this is the kind of thing I want to achieve. Like he will say that I want to understand why my market for certain product is going down. He won't tell you that the solution for this is a data warehouse. It's, as a consultant, you will have to tell him that, okay, this is this particular requirement of yours can be achieved by building a data warehouse and making different kinds of reports, and looking at the reports you will know what to change in your marketing strategy or in your approach or in your production lines to improve the profit of your company or the sales of your product. So let's take an example in this case. To explain these approaches, so let's first define these two approaches, right? Like the ones you see on this slide. Yeah, the historical fact in 1998, Bill Inman had stated the single most important issue facing the IT manager this year is whether to build the data warehouse first or the data mart first. So this was a question asked by Bill and Inman. So with this questions is what the two approaches are. With this question in mind is what these two approaches have been designed. So first approach is top-down approach. Second approach is bottom-up approach. Which is top and which is the bottom? That is the question here, right? So when in a top-down approach, you will first build a data warehouse. So you will first build a data warehouse in a top-down approach. So your top is the data warehouse, then you will flow down to different departments in the which are the data marts. So as I told you before, right, building a data warehouse and keeping the whole enterprise data requirement in view is a very huge thing. In real-time scenario, this top-down approach is not really always the solution. It's a solution in a company where they want to do research or they want to invest so much on a particular. I have worked in projects where they wanted this to be an approach. So they don't have a particular business scenario in mind or business requirement in mind. They would say that we want to be competitive in the market, so give me a data warehouse solution. So we, as a consultant, we will go and propose this is a data warehouse solution, and these are your different departments which can have these different data marts from taken out of this data warehouse, and they can use this data warehouse information specific to their requirement, and then do their analysis. So this is a complete innovative approach which needs a lot of thinking. So this is a top-down approach where you build the data warehouse first from your OLTP system, make sure that it is as enterprise-wide as it can and as scalable as it can be, and then you can, so that this can be used by different systems which are going to come in the future or current operating systems, and it supplies, it gets information, it gives information to all these systems, being a holistic enterprise. That's called an enterprise data warehouse. So this is a top-down approach, and the bottom-up approach is the reverse, which is the easier way. You build a data mart based on what requirement you have in your particular department, and you collect the information from each department what they need, which is already available in the data mart, and then combine and make a data warehouse and do the consolidated reporting on top of the data mart. So that is bottom-up approach, which is much easier and which is much quicker, and mostly this is the kind of approach which many companies take. Next slide, which is about the top-down approach. So I explained to you what is the top-down approach in brief. So a top-down approach is when a data warehouse is built first, and then you go on to build the data marts. So yeah, so that means that the data warehouse is built on top of the OLTP system. It has information from all the information needed for all the departments in a single data warehouse. Might not be that all the data in the data warehouse is related. It could be independent data also, and maybe it's segregated based on departments. But it has consolidated data from the OLTP systems, all the OLTP systems, and it will have information required for the function of each individual data marts for different different departments. So the advantages of having this top-down approach, we talked about few disadvantages, which is complicated, time consuming, but there are certain advantages, otherwise we won't have this approach at all, right? The advantages is that it will, when you have a single data warehouse built on top of a OLTP system, the information is centrally accessed by each data mart, and it's centrally located, and the time of and the data marts are same. What I mean by time variant, say the data warehouse is a monthly updated system. Your data mart cannot be daily updated, it has to be monthly. So all the data available across all these systems will be on a certain particular time period. So everybody looking at certain data in any of these systems will have the same information at the same time. So that is a very huge advantage, because different people looking at different systems, if they have different view, then they won't have the holistic information. It could be said they have wrong information. It could be, yeah, in a way it could be said that it's a wrong information, because some people have more updated data than others. So that is a disadvantage in case of, it's actually not a disadvantage. I shouldn't say it's a disadvantage. It's just a requirement. So if they don't care about the time of the data, then this business scenario is gone. But I'm just telling you what is the advantage of having a centralized data warehouse before it distributed into different data marts. So they will have similar information at the same time. And yeah, and the disadvantage we already talked about few. One of them is it's huge data, and it is like it takes a lot of effort and time and cost to implement that particular model, that particular approach. The data warehouse using that particular approach, the top-down approach. And this approach is the nomenclature, if you look at the nomenclature, it's called Inman approach, from the Bill and Inman. The next approach is bottom-up approach, where you have an OLTP system, which is your transaction system. You build data marts required by different departments and by specific requirements for specific reports for specific people. Excuse me. And that data mart, that subject specific data marts will be combined together to form a data warehouse. So in this, if you see in the figure, you see in the picture, you see that there's a OLTP source on the left side, and then there are 3 data marts, and then finally there is a data warehouse. So the arrow from OLTP to data mart 1 and the arrow to OLTP to data mart 2 is independent, right? So maybe that, yeah, they are independent. You can have your data marts 1, 2 and 3 updated at different times. You can have different kinds of data in these data marts. Maybe they are not time bound, they are not time related across. So it's independent. So you can keep your reports in one going on correctly, without thinking about what is happening with data mart 3. So they're totally independent data marts. So this is a bottom-up approach. So you have a OLTP system, you load your own specific data marts 1, 2, and 3, and then you consolidate all the data marts in the in all these three, and then form a data warehouse. So this is called the bottom-up approach, which is easier than the top-down approach. So it is obviously quicker to build build a data warehouse using this approach. And yeah, the third advantage which is mentioned in this PPT, we already discussed. It's broken down, so it's easier to manage. So you can manage your whatever happens in one data mart 1 that doesn't affect the data mart 2 operation. So it's easier to manage. And the third advantage you can see is usually startups go for such approaches because it's cost effective. It is and it's cost effective, and then it's easier to implement, and you don't need much heavy duty resources to implement these data marts. And then it like you are not saying that okay, once I build the data mart, I don't have to build a data warehouse. You can always add on systems based on your budget constraints and everything. You can add on systems later and then combine it to become a data warehouse. So that's why the startups go with these approaches, because they are scalable. They can create a data warehouse anytime they want using these data marts, and then it's cost effective, which I already said. Okay, so that's about these two approaches. So the next slide, we are going to talk about operational data store. What is an operational data store or an ODS? In day-to-day data warehousing projects, you will hear ODS. It's the abbreviation of operational data store. What is exactly an operational data store, and why do we actually need it? If you look at the diagram, you could picture just below, you see that there are different applications. It could be OLTP, different applications, which OLTP applications. There are different sources, OLTP sources. Then it goes into a ODS, operational data store, and then it goes into a data warehouse. ODS basically is a kind of data warehouse, but it just stores the current data. So if you go by the definition of a data warehouse, which we discussed in the previous class, it says that data warehouse is a subject oriented, time variant, and it keeps historical data, and the data might not be current, it will be periodic, correct? But ODS will be current data. So why do we actually need a ODS if we have a data warehouse? Maybe there are two different business scenarios. Say let's take an example, like we have a call center team which is sitting to address your customer queries, but they cannot go into your OLTP system every day, which has so many records, so many transactions a particular customer did on that day, to see what the customer is actually trying to say in his complaint. So he wants the current transaction which he has performed. So ODS is a current data warehouse, you can say. So by definition, the data warehouse is a time variant system which has historical, and it's not updated daily. It keeps information only periodically and stuff, but ODS will have information which is current. So that in this example which I just pointed out, in a customer in a call center where they are taking customer queries, they want to look at the current data which is happening right now or just happened just happened today. So that's ODS, where you have the frequency of the data doesn't match the data warehouse. Data warehouse could be a monthly updated system. The ODS could be a very current data, which call center need to look at before they answer to the customer query. But this the needs of the call center might not be that they can might not be fulfilled by the transaction data, by looking at the transaction data. They might need certain level of summarized data or certain level of statistical view of the OLTP system, which might not be available in the raw data. So that's why we need a ODS, which is operational data store. So it is, by the name itself, you can say that operational data store is needed for the day-to-day operation. That's why it's called the operational data store. So these kind of ODS systems are basically used for doing ad hoc reporting. So maybe you like one of my clients had this requirement where they have a they have a SAP system, which is a transaction system, and they have SAP Business Warehouse, which is a business warehouse built on top of the OLTP transaction system. But they needed something. The Business Warehouse is a monthly updated system. So the SAP Business Warehouse, they would fetch the data from the OLTP system, load it into the BW on monthly basis. So the reports you see in the Business Warehouse is the monthly view of an enterprise-wide transactions. But they had a requirement to have a call center implemented for their customer. It was called the ticketing system. It was a ticketing system, so where the customer can call in and then they can report. But customers will call anytime, but you can't tell them that, okay, I don't have your data yet in my data warehouse, please call me after a month. That is not how you can handle the day-to-day operations, right? So for that, they had a requirement to create an operational data store in which they had data for 15 days, every previous 15 days. So they will have customers calling in, and then if there is a recurring cases for that customer, they will keep the data updated back into the data store. So they will keep previous 15 days of data always in the operational data store, so they can always access the data frequently, and they can do ad hoc queries and frequent queries so that the performance is not slow. So when a customer is on call and then he's telling you certain queries and you're not able to look at the data, so and you're taking so much time to fetch the data. So that's what will happen if you have a data warehouse in the backend. So what will happen, you are trying to fetch data from a historical data warehouse which has data from like last 50 years, and then you fire a query into that data warehouse and it takes like hours before you can actually see what's happening with this customer. So that is not possible. So you want a operational data store which is quick and handy and you can do quick operations. So that is why a ODS is needed. And ODS is frequently updated. It keeps, most of the time it's like updated every day, maybe even hourly, or even on half an hour basis, depends on the business requirement. So that is basically an ODS. So what is the, so we discussed what is an ODS, what is the concept, why do we have it, why, and we also discussed why it is advantageous. It gives you, the last point in this slide, you can see it provides improved access to the critical and current operational data. Yeah, so that's an advantage of having a ODS. So let's move on to our next slide, which talks about talks more about the operational data. So here in this slide, we are discussing an example. I think it's the similar example which we just discussed. Yeah, we place a when we have when we place an order on an e-commerce site and we call up the call center to inquire about the status. So it's basically the same example we just discussed now. So I will skip this slide. Yeah. Except for the last point, when the status changes the OLTP. Yeah. So they're just saying that a data warehouse might not have the updated data, while a ODS will have the updated data, just because there is a time lag between updation. So we already discussed this. So I will skip this slide. Let's move on to the next slide. So in this slide, we are just summarizing what all we discussed in the module 1 till now. So the first point is the definition of a data warehouse, central location. Data can be consolidated from multiple data sources. We discussed about what is the definition of Bill and Inman's definition of a data warehouse. It's a subject-oriented, integrated, non-volatile, and time variant. I explained time variant. Non-volatile, I suppose they told you before. Non-volatile means the data doesn't disappear from a data warehouse. That means we keep historical data inside, and it doesn't vanish as soon as the data from the OLTP system vanishes. It will always be there. For example, if a product was there with this company, product was being it's like, say, a car, model of a car was being manufactured by a particular company, but it's not being manufactured anymore. It might not be there in the OLTP master data or ODS system, but it will always be there in a data warehouse. It won't go, and it is integrated because it's coming from multiple sources. There are two types of information systems we discussed about, OLTP and OLAP. OLTP, online transaction processing, which is basically all your transaction application systems like Oracle applications, SAP systems, or any other custom application transaction systems, billing systems, order processing systems, whatever. And OLAP is online analytical processing, which is a reporting system. OLTP system is used to record everyday transaction, and OLAP is summarized data. Okay, we discussed about this. Data Mart, we just went through what are the types of Data Mart, what is a Data Mart, what is the difference between Data Mart and Data Warehouse, and then we discussed about what is the different types of approaches to build a data warehouse. One is top down, one is bottom up, what are their advantages, what are their disadvantages. And lastly we discussed about the ODS and its advantages, why it's used, and what is its requirement, what is the advantage of using a ODS, what are business scenarios in which ODS can be used. Define more about what are dimensions, dimension tables. The objects of the subjects are called dimensions. So this is like just playing with words. So objects of the subject is called the dimension. So the categories, it's similar to what we just discussed. So the categories in which information can be split across or viewed from is a dimension, and all the related information for that category is placed inside the dimension. So the table that describes the dimension involved is called a dimension table. So that particular category, when stored in a particular table and has all the related information for that particular dimension, forms the dimension table. So to explain this, let's take an example. We just said that we will have a patient dimension and a hospital dimension, right? So in this, the hospital dimension will have all the information needed to define the dimension inside that table. So that, what I mean by that is, so if a hospital dimension has information for the hospital name, hospital ID, and the address of the hospital, number of say number of doctors in that hospital, or whatever other information you want to give about that hospital in that dimension table. So all the information related to that dimension will be present in that dimension. And later we will see about the fact tables. So this particular hospital dimension will have all related information for an hospital. So you shouldn't put the data related to a hospital in another table, just or repeat the data in another table. All these things we will see how to form a dimensions in our normal forms. But basically a dimension table is a category of information. Dividing a data warehouse project into dimension provides structured information for reporting purpose. So maintaining a data warehouse is a complex thing, right? So to have a structured data warehouse, you should always categorize your information into different tables so that you don't have to repeat we will see why we have dimension tables, why we split the data into dimension and fact later on, and how it helps to organize the data. I will just give you an example, right? So say you have your day-to-day transaction. You form a data warehouse where you store your information of your in the previous example we saw hospital data, right? So you have your table where you have your day-to-day transaction, where you have all the information for that transaction, like which patient came, what is the name of the patient, what was the which was the doctor who was the doctor who attended the patient, what is the doctor's name, what is doctor's address, what is doctor's passport number, what is the patient's passport number, what is the patient's address, every information in one table. Then you will have multiple records, repetitive, right? So what if the doctor changes the address? So you will have the same doctor with different addresses in this same data warehouse, right? So the information is not consistent, correct? So for the same doctor, maybe the doctor got married and he changed his name. So you will have different names for the same doctor's passport ID. So it is not consistent, and maintaining that system would be very difficult if you have to update all the data. So that's why you categorize different dimensions so that you can look into the dimensions for extra information for that dimension, for that category of data. So that's what it means to organize a data warehouse. Don't worry about it now. I just gave an example. We will discuss a lot deeper in the next slides. So a dimension table. It is to be noted that the business users or the end users who generate reports fire queries on these dimension tables because they can descriptive information. So what they mean to say, we already discussed this, right? So you have a day-to-day information, you have your categories. So the user who is trying to generate a report, he will access this dimension table to give a meaning to your data you are fetching. So if he wants to see which all customers, how many customers, or say which all customers bought this product on this day. So he will access all these three dimensions. Like for getting the information of the customer, he will go to the customer dimension, get the information. To getting the information of the product, the particular product we are talking about, he will go to the product table. And on that date means you have to see what is the which date are you talking about. So maybe your report is based on order date, so you just get the data for that particular order date for that particular customer and that particular product. So basically what I mean to say here is the quality of the dimension table has to be accurate, because the executive who is trying to generate reports is going to access this table day in and day out for his reports. So these tables are very important in your data warehouse. To maintaining this table is very important. So in this session we'll be discussing different concepts of how to maintain data, different dimension tables. So let's look at this dimension table in this slide, which is for an e-commerce company. I think we already discussed these dimensions separately, so I think we can move ahead. Okay, so with all this equipped with all this information, let's see what is exactly the fact. Let's see what is the definition written here. A fact is a measure that can be summed, averaged, and manipulated. So we already discussed that you can do mathematical functions on the fact, and it can be manipulated and when summarized. You can do averages, you can get averages, you can, yeah. So basically, it's measurable information in your day-to-day transaction. A dimension is a link to the fact. So there is a fact table and you have multiple dimension linked to it, which we already saw in our example. A fact table contains two kinds of data, a dimension key and a measure. So we discussed that your amount fact table will contain your customer ID, which is the key, product ID, which is another key, and your date, or the date ID. You can put the date ID inside. And your quantity table will have your customer ID, the product ID, and the date key. So these three keys, and then there will be a column quantity, which will store the actual measure. So that's about the fact table. Now the combination of these two is called a data model. It forms a data model for your data warehouse. Now to go further into understanding the dimensions and different types of dimensions, let's move on to the next slide, which is slide number 32, where we will talk about different types of dimensions, namely conformed dimensions, degenerated dimensions, junk dimensions, slowly changing dimensions, and role-playing dimensions. We are going to look into each and every one of them one after another. So don't get scared by the nomenclature. It's once you know the concept behind you will relate to the name which you see, which is assigned to them. So first we'll be looking into slowly changing dimensions. So what exactly is the slowly changing? Why is it called slowly changing dimensions? In a data warehousing concept, when we split the data into different categories, we split the categories so that we maintain the category of the data in a separate table, which is more or less static. It is not static, but it is more or less static. Like a customer name will change, but it will not change frequently. So, and a product name might change, but it will not change frequently. So that is part of the dimension. So these are the dimensions which are not changing, but it could change. So this is slowly changing dimension. So in our hospital example, if you see, you will have a dimensions for, we discussed that we can have a dimension for hospitals, right? So in that hospital, the address of the hospital might not change every day, but it could change like say in a year's time, or in a month's time, or maybe in 5 years time. They could change their address location. So this change of the information about the dimension is called slowly changing. So we discussed our fact table and dimension table, right? So we also discussed that dimension table should be easily maintainable, right? So now with this concept, we will see why it is complicated to uh, maintain fact and dimension in the same table. So if we have fact and dimension in the same table and then the data changes, you have to change the whole fact table. You have to change, update everything inside the fact table. We discussed this before. So if a customer name changes and you store the data in your fact table, then you have to change all the records of that customer inside that fact table. But since we are only putting the key of that in our fact table, the key will point back to the same. If the data changes, the key won't change. So the fact table, you wouldn't have to change the fact table. You just have to change the dimension table, create update the record in the dimension table, which will be only one record. This customer could be related to multiple record in your fact table, but you will only change one record in the dimension table. Then it will affect all the fact information when you generate your report. So your report will be consistent. It will show same address for the same customer if you fetch data for this month or for previous month. So your data is consistent even if you change. So that's why I said maintenance. If you split the data into different categories, maintaining the data, organizing the data in a structured way will help you to maintain your data warehouse properly. So coming back to slowly changing dimensions. So I said dimension might not change frequently, but it could change occasionally. So that's why it's called slowly changing dimension. So in this slide, they have given an example. Let's consider an example of a person changing his or her city from city 1 to city 2. It does not happen regularly, right? But it could happen that the person gets transferred from one place to another. He plans to move from one place to another for his new job. So he wants to update his records then to the new address. So that the location dimension, so the person's record might be stored in a fact table, but the dimension for that will be a location dimension where he will change his location. Only the location dimension will change. The person record in the fact table might not change. So it's a similar example to our hospital example. Okay, so how do we actually maintain these slowly changing dimensions? So there are by data warehousing concepts, there are three different types of handling this system. So what I mean by handling this system, handling these dimensions is how much in what way you want to actually update the data in your dimensions. Do you want to keep the historical data, like if I change from city 1 to city 2, do you want to store the data of city 1? When did I change from city 1 to city 2? Do you want to keep that information in your system, or do you want to just keep the current information only of that dimension? Or like how you want to maintain that slowly changing dimension is what is defined in these three methods. First is the type 1 dimension, second is the type 2 slowly changing dimension, third is the type 3 slowly changing dimension. So type 1 is a simple slowly SCD in which you actually override the old value. So you change your data from city 1 to city 2, you just keep city 2. You don't keep your city 1, or neither do you keep when it was changed from city 1 to city 2 or whatever. The next one is, so in the first scenario, you are just deleting the old value, so you don't know where he stayed before. In the type 2, you add a new record. So you don't change the key, but you add a new record in your dimension table to change the address from city 1 to city 2, right? So you will always know where he was at a certain point in time and when he actually changed, because you will have all the historical information. And in the fact, you will actually get the data based on your requirement, whether you want to see now, or because you have both the information available in your dimension. So you can do your querying based on how you want to see your report, whether you want to see the current data or the previous data. So you have new record in your table. And type 3 dimension is another, type 3 SCD is another way in which you actually add a new column. So in this, the first case you just overwrite, second case you add a new record in your dimension table, third is you add a new column in your dimension table. Column as in previous location, current location. So you will have two columns. Your previous location is city 2, city 1, then your current location is city 2. But what if he changes from city 2 to city 3? You will have to add another column, or you will delete the city 1, you put the city 2 there and add the city 1, city 3 in the current column. So either you keep two columns only, or you add another column for the new data which is coming in. So these are the three different ways. We will see with examples in the later slides. So type 1, update the record, keep only one current record. Second SCD is add a new row. You have historical information, you can keep adding new rows. Third is you add a new column for each incoming, each changing dimension. So let's look into these different types of SCD in the upcoming slides. So let's see first the type 1, override the old value, right? So SCD type 1 is you have one record, and then once James changes the city, it goes to Chicago from New York in 2004, right? So, but the thing is that you, at this point in time, after the change is done, you would never know where James was in 2000. Say you generate a report, since our data warehouse is a historical system, you will have data from 2000 to 2004, right? But if you have a specific requirement wherein you want to know where this person was in 2000, it will show Chicago, because you don't have the information that he stayed in New York in 2000, not in Chicago. But if your reports doesn't need the information that where he was at that point, then you might not, you don't care. So you just you save space and store only one record which is showing you the current information. So that is the advantage, that it is easy and it is saving huge space, because every time everybody changes, they will have new records as in type 2, then it will consume a lot of space, and there's with space there's cost involved. That is the advantage of this system. The disadvantage of this system is no history maintained, which we discussed just now. Okay, so let's look into our next slowly changing dimension, which is slowly changing dimension type 2. In this, as I told, that we will be adding a new record. So you see the ID didn't change, the year changed, the information changed wherever needed, the ID didn't change. The first record in 2000 was 1, the ID was 1, the year was 2000, the name was James, and the city was New York. So James stayed in 2000 in New York, and 2004 he changed to Chicago. So now in our fact tables, when we generate a report, we have a choice. to mention the year as a filter to get the location on 2000, but if and we can put the year as 2004 and we'll get Chicago. So our report has this flexibility to fetch the correct information based on our requirement. So the advantage is we have history, and the disadvantage is huge space. But huge space is also dependent on the kind of dimension we have. Like in this case, the dimension we have is a location dimension maybe, and say we have only like 300 people in our organization. So it's better to how many people will keep changing their location day in and day out. So the space doesn't really matter in that scenario. So we can have SCD2 and maintain the historical data for that person. So it totally depends on the business scenario, as I said before. So that's about CD2 dimension, type 2 slowly changing dimension. Okay, so yeah, there are few challenges which we have to go through and see what kind of challenges we face in SCD2. It's actually, the concept itself is a bit difficult, and with lot of changes coming in, the concept is for slowly changing dimension, but the real life scenario is not always ideal, right? So we say that okay, this dimension only changes slowly, but what if the dimension changes very fast? So it's very difficult to maintain these dimensions. And how many times do we keep updating these dimensions? Like what is the, so all these process of updation and the query performance and performance tuning, because you will have historical data in your dimension, you will have multiple facts, then while fetching you have to filter it on different things, you will have subqueries. So all these things makes it very complicated to maintain. So yeah, it has historical information, it has an advantage, but it also has disadvantages like query performance. It will be difficult to maintain new records. What if there are multiple updates? Then you will have like thousands of records. Then it is relatively difficult to determine which record is most recent. A subquery has to be written to fetch the most recent record. To overcome these two approaches, to indicate the most current record. Actually, yeah. So if you have there are many ways in which you can access the current record in the dimension, right? So in some data models you will see they will have dates. Like in this case they have shown that from start date to end date, and they have shown the status or the expiry date of that particular record. So if you see the first record, it started on January 1st of January 2000, and the end date is like unlimited. So the current record will have end date which cannot be reached, so it is always valid, and that is 31st/12/9999. So which is a random date which is valid till forever. But if you see when there is a new record added, the first record is expired, say, and change the date of expiry to the date when the new record was added, and then you see 31st December 2003 the end date, and the start date is January 1st 2004. So 1st of January 2004 is the start date for the new record, and the end date is forever. So you can see that's how it is maintained to find out which is the current record. So there's another way to find out current record. You just add a current flag. So instead of having two columns, you just won't have the date information in that. You just want current information, then you will have current date and the record date. So in using that, you will have current date column which will tell you which is the, sorry, current flag which will tell you which record is the current record. The rest will be say marked as N. The only current record will be marked as Y, and then you will have a record date on which date this record was entered. Using combination of these two columns you can achieve the same which is being achieved by having start date and end date. So there are different ways of storing this information to have this two issues resolved. Having a subquery and maintaining the dimension table. So we discussed about another way to do the find out the current record in the dimension. It's the current flag indicator Y and N. You see the first record as marked as Y, and when the second record comes in the type 2 dimension, the first record is expired and the current flag is set to N and the next flag is set to Y. So this is the way when you generate a report you access only the current record using the filter Y. Okay, so the third type of dimension is the add new column, right? We discussed first one was to update the record. So type 2 is to add a new row. The third one is to add a new column. So in this, as I told in the previous example, city 1, city 2, where you add a new column and say my old city was New York, my old year is my current city is New York and my old city is blank when there is first record, only when there is only one first record, and when the dimension changes you change the city to new city on that particular day, and the old city you will update those two columns, old city and the old year, when actually the old city changed from old to new. So in year 2000 the New York City changed, he changed his location from New York to Chicago. So you will expire that column and add it into these extra columns which you have added. So this is another technique to store the historical data. So but in this case, as I told, you have to keep adding, or you can only keep two, old and the current. In this case you cannot maintain all the history. You cannot even keep adding new columns for every new city he changes to. So this scenario is used when you don't have to store all the history as mentioned in this example. So in this example you just store two previous location, current and the previous, one previous and one current. What else? Disadvantages, we discussed. The disadvantages is disadvantage of this approach is that each attribute there must be two columns, extra columns, one indicating the current value and another indicating. So if you, in this case we are just maintaining city's old and new value, right? What if the person name changes? So you have to add old name and the date when the name changes, old name, year. So for every column you will have three columns, three extra columns in your table. So any attribute you will have three extra columns. So it's all about space. And also another disadvantage would be that you can only store two values at a time. With this we have finished the slowly changing dimensions, and we have types of dimensions from now on. A confirmed dimension is a dimension which does not change, like okay, I will take an example, right? So to imagine a franchise, let's take the example which is posted in this slide. In a franchise we have a product which has product ID, product name, and product source. And the measures of these product will be the number of products sold, amount of that product sold, revenue generated by the product, etc., so on and so forth. So there are two fact tables, which the one fact table determines the number of products, another fact table determines the quantity, the revenue generated. So it's similar to what we discussed, the quantity and the amount fact table. So this is very much similar to our previous example, so I might not have to explain it in deep. So what exactly is a confirmed dimension using this example? So say take an example of a geographic location of the geographic location dimension and a customer dimension. These two dimensions are being shared by two different fact tables, which are our products, number of products, and the revenue generated by the fact table. So the units inside the products fact table gives you the number of units sold and the units sold in a geography to a customer. So the customer, the whole combination gives you fact about how much revenue was generated by a customer by using how many products in which location, in which geographical location. So that is the overall report which can be generated by this dimension.